Hi and welcome back to the lab. And today here on the bench we have a XIEGU XPA-125B. So that is a 100 watt power amplifier for shortwave, and well, that is has been especially produced or developed for QRP radios. And the little power amplifier came in because there is a problem with the switching. So I mean with switching it on and switching it off. So that is not given any longer, and the owner told me that everything else is working fine, but he cannot really switch the power amplifier on and off. So let's see what we can do. Alright, and here is our little PA and everything is prepared so far. So let us connect here the PA to our power supply, and so that is sufficient, so we do not need the big power supply. This is good. Then we have 3 digits here and we see exactly what's going on. So let's see. Oh, wow, what that? It is directly switching on. Okay, so that was not expected. Okay, so 13.8 volt and 265 milliamps, and let me see if we can switch. Ah yeah, okay, so on, off, so that is working, and I can switch the ATU, so that is working as well. Can I move here the band? Yes, obviously that is possible. So okay, so what have we seen? So it directly switched in, so maybe that it remembered how it was switched off. So let me try to switch it off. Ah, okay. Okay, but there is still something in the display. Okay, and look there. So we have 300 milliamps. So it is still something going on here. Let me try to switch it back in. No, it is not possible. We cannot switch it back on. So look over there. When I try to press the button here, okay, something is happening, as you can see. So that's what I meant. There we can three digits, and that is good because we recognize that while we are pressing here the button, something is happening. But I cannot switch on, you know, our little PA. Okay, so let me take it away from our power supply and let's try it again. Ah, okay, so it is directly switching on. That is interesting. Okay, let's try to switch it off. And you see, it is not recognizing directly. Ah, okay, and not sure if you can see that here. So there is still something in or on the display. So I mean, okay, our backlight is gone and the rest of the display as well, but still there is something still there. And again, we have current flow, which is of course not normal. And let me try if I can switch it on, and no. Okay, so that means you know, it is right what we have been told. So there's something wrong with switching. Okay, so that means we simply have to open our PA and we need to look inside what's going on here. And a tip with this little XIEGUs, it is always good to take the front panel away, because you cannot easily lift as we are used to open you know, the sides here and then to lift up the lid. So that is not possible. So it is always a good idea to really take off the front panel first, and then it is quite easy. Okay, and I've removed now here the screws, and then it is the best way to try to get here the front away. But as you can see, it is very, very stiff, everything here, and you can't really move it. So that means we need to go with a little bit more force to bring it away here from the frame. And the easiest way is to take a hammer and of course a piece of wood, and then carefully just give here some hits to, you know, the frame on both sides, but very gentle, not too hard, and then you should be able finally to take it away. And you have to be careful because here is a ribbon cable, but then you can already put it here onto the bench, and you see how it is constructed. So it is really difficult, so you cannot lift, as I said, you cannot easily lift the lid, and that is why I need to take here the front panel first away from the housing. And then, of course, it is easy. So you simply need to take out here the screws, and then we will be able to get in. So that's it then. Okay, so all the screws are out, and let's see if it works now. And again, you see, it is somewhat hard to get it easily away here, but we will get it done. Okay, and here we go. So that is what we wanted to have. Alright, and here's our PCB. So what we easily can see, so here is our microprocessor, and here we have our voltage regulators, and this here is our switching relay to simply switch the PA on and off. So if it is off, it is running in a loop, so that means the PA is completely disconnected from our signal pass if we don't need it, right? So we have here the low pass filtering, and we have here, so this section is the automatic tuner, and what we can see as well, we have here our power amplifier, two transistors, MOSFET transistors, and well, we have here, this is the IC to you know, turn here the relays on and off to get the right low pass filter into the signal pass. And therefore let's of course start with our power supply. So we need to check if we have all voltages as we need it. Okay, so first let's again connect our power supply to the PA. And as we already know it, it is switching on, very nice. And now let me reposition the camera and let us check the voltages.
Okay, so mainly we have three voltages here.
And that is basically here our supply voltage, and we see 12.0, which is totally fine. And at the output we should see 5 volt, which we do, as you can see. And then of course we have here our 3.3 volts. So that means basically our 3 volts are present. And of course I believe it is this here, it is this. Let me double check which one, yeah, this one. So that is our 13.1, so that is more or less the input voltage here. And of course we always have a little drop because already here this diode has a 0.2, which makes all sense, and then there are some other components in between, so that we have here at the input 12, 5, and then our 3.3, and that are basically all the needed voltage, and we see that that is all definitely fine. Well, this PA is known as that there are burned out components within our power supply section, which is all around yeah, this relay literally, and then of course, as I already told you, the 5 volt regulator, the 3.3 volt regulator, and there are some switching transistors here around. We have one here and we have one there, and here is another switching transistors, and that all are components which are known for burning for different reasons. If you have the first revision, then that is what very often happens. This here is already the revision 1.03, and normally we should not have that burning here. But on the other hand, here the SWR bridge, which is checking your output power compared to your input power, because we have here also a bridge which is checking the input SWR and the input power compared to, of course, here our output power. And there we very often see burnt components as well, that we see burnt relays, so that all happens. And of course we see very often that the output transistors, so the power amplifier itself, has burnt transistors. So that are mainly the problems which are known with this power amplifier. But here we have checked everything very, very carefully, and there are definitely no burnt components. So you see, that is then already a little bit more difficult, but everything is fine. So no burnt components whatsoever. Everything is fine, no problem. That means we need to dive a little bit deeper here into our schematic, and let's try to find out why it is not really reacting on pressing the on and off button. So let's see what's going on here. Okay, so how can we start? Of course, we have here the connector, which is going, as you see, to the front panel where we have our keys. And of course, maybe something is wrong here, so that when we press that there is something not really working. But on the other hand, I don't believe that, because we have seen when we press it several times, then suddenly it is switching somehow, but not completely. So we see that we have still the current consumption. So there must be another reason for that. But anyways, we need simply to see if that is getting to the component which is, using it for switching the power amplifier on and off. So that would be the next step, and we need to find the involved components where we see where you get all the switching information to, in order to get the PA doing what you expect from the PA to do. Okay, so what steps can we go? So we know this is K9, and K9 is, if you like, switching on the power amplifier, not the power amplifier in general. So that is switching, that we switch off, if you like, the loop. I mean, we can connect a radio, and without having the PA switched on, the signal needs to go through, right? That is the loop. And when this relay gets engaged, that means that our power amplifier here gets fired up. So then the radio is expecting the input signal, which of course coming here in, and gets through our power amplifier to the output transformer, over our low pass filters, over our SWR bridge, where we basically checking the power which is going in the direction of our output. And therefore let us check what is needed to get this relay here switched. So then maybe we understand what happens when we press our on and off button, because that must have a consequence, of course, because otherwise that all wouldn't work together. And that is something we should try to find out when we try to understand, the schematic. Oh boy, that was a lot of theory. And now we need to go really into the circuit and we need testing. But before we do that, and that you can follow what I'm doing, I have to show you the switching circuit and where I'm going to probe. Okay, forgive me, and I hope it is not getting too boring for you, but when I start probing, then you know what I'm doing. So look here, that is literally what we have already tested. So that is a 5-volt regulator, and here's our 3.3-volt regulator. So you see the 5-volt output from here goes into the 3.3, and we have the 3.3-volt output. Our 12-volt you see here, which goes from here away, but we have here voltage extern, and that is more or less where it comes in. Look here, so that are our both terminals which are delivering our power amplifier with our voltage 13.8 normally, and you see here we have our volt extern. Again, volt extern comes into here, goes over this little switching MOSFET transistor, right? Then we have our regulator and so forth and so forth. Important as well is here, oh, you can't see it, sorry. Here we see key power line. So where is that coming from? Look here, so that is our connector coming from the front panel. And you see here key power line. So that is a power line. When we press our on-off button, that is what we should see. Let me go back. That is what we should see here at this diode, okay? So that is a double pack diode, okay? And what we see here, when we press key power line, then we set power key to ground. Where's power key? Let me show you that. Power key is here directly at the processor, okay? So we press our power key, that means we get a low here to the processor. Consequently, we will get here to this switching transistor a power engage, right? So that needs to be a positive voltage. This transistor, this is a so-called digital transistor, would switch to ground. And that means that we pull here the input of this P-channel MOSFET to ground, okay? And that means that we get here a current flow, or we have then voltage present at our both voltage regulators. So that is how it is working. And of course, we want to now check, do we have the power engage? Do we have the right voltage drop here? And do we see, finally, when we press our on button, do we see here low? Because that would then indicate, okay, from the front panel, everything what comes over from the front panel is right. So that means we now start to investigate this circuit. And as you see, our power amplifier is already switched on. And you can see it here on the lit display. I mean, that is what we have seen. We put our plug into the power supply and it directly starts, right? So that is what we have seen before. And now, according to our manual, we have down here our Q11, which is a little digital transistor, okay? And we have here our Q10, which is this guy here. So that is a little P-channel MOSFET transistor. So that is a switching transistor, okay? And we know that we need to see here at our Q11 on the base, we need to see the positive voltage in order that this little transistor is switching through. And that is now what we check if we have all the right informations here on the components in order to diagnose what's really going on here. So let's probe at the digital transistor, and we know that we get the engage signal to our base. So there we should see a positive voltage. Let's go down and we see 3.2 volt. So that is directly as we've seen it from our processor. So that is fine. And that means if this transistor is engaged, we should see at the collector a low. Let's see if we have a low down there. 61 millivolt, exactly. So that is low, and that means that it is pulling the MOSFET, the P-channel MOSFET, lower on its gate than it is at the input. And that means, so there is a 1 kilo ohm resistor in between, something like that. So it should be somewhere our gate voltage was 6 volt, 7 volt, something around that. Let us check. So that is now the MOSFET here. 8 volt. Okay, so that is a lower voltage as we have it at the input. So that here is our input at the MOSFET, and you see that is 13 volt, which means, okay, we have then on the other side, so on the drain side, so remember it's a P channel, not an N channel. So we have the output on the drain, which is here, and we have our 12 volt. And that is exactly the voltage which we have seen here at the input of our regulator. So that all is definitely fine. Now we want to know if the front panel, the on-on switch, is working properly. And remember the little double pack diode, so the D22, and the D22 is down there. So here at this point, so that is the cathode side, the common cathode, right? And there we should see a voltage, so the 2.5 volt is from the processor. So that means it is a high, which should be pulled down by pressing our on-off button, okay? And on one side, the one side here from the input is connected to the collector of our Q11, and that is low because our Q11 is engaged as we have seen it before. And the other side is then from the processor. The 2.6 volt is from the processor. Fine so far. That means now when we go back here to our on-off switch, and now when I press I'm here, you know, with my thumb, I'm here at the on-off switch, and when we press it, we should see that the voltage is going to 0. Let's test that. Wow, here we are, 1 millivolt. So that is definitely low. You can see that. That means the information that we want to switch off our PA is present. And I see now, look here, we can see that our display is dark, but there are, as we have seen it before, some artifacts, right? So that means, because that the display is dark with some artifacts, so that means that, you know, at our little digital transistor, so we have told by pressing the on-off button, we have told the processor switch off, okay? And that means our power engage should not any longer present at Q11. So let me go down to Q11, and this here is the base of our digital transistor, and look here, so it is off. So normally we should not see still our power consumption, because we have told the processor that it should switch off, and somehow that happened, because otherwise we wouldn't see here a 0. Otherwise, or if we have not told the processor, hey, switch off, then we would still here see our 3 point something. That means if this here is switched off, right, we should not see any longer our 3.3 volt at our voltage regulator, which is supplying here our processor. So let's see what we have there. Look here, so we have still 3.2 volt, which is wrong, of course, because our little MOSFET, P-channel MOSFET, should have switched this voltages off. So that means we have obviously our 5 volt still. Also the display is dark, okay, and still we have our 12 volt. Oops, look here, so I was engaging it somehow. Let me double check here. Now it's back off once again. Display is dark. 3.2, 5, and here 12, which is definitely wrong. Still, we have 0 at Q11, which is true. And that means if that is 0, we should see 13 volt at its collector. And we have 13 volt. So that definitely means our Q11 is switched off. And that means we have full potential at our base, gate of our MOSFET. Let me check. 13 volt, I expect. Yes, we have. So that is a gate. And that means, in this case, our MOSFET is not allowed to switch through. So that means on our drain, we should see nothing. But look here, we have 12 volt. So that brings me to the conclusion that most likely our little MOSFET is burned. Because once again, we have here input 13.3. We have here our gate voltage, which is 13.31, which is telling me this little MOSFET should be closed. So that means no current can flow. But when I go to the drain connection here, I see that we have 12 volt. And that is also, we do not have power engaged on our little digital transistor. And that then is, the logical consequence is that something is wrong with our little P-channel MOSFET. I hope that was not too confusing for you, so therefore we repeated what we have done. Look here. So if the power engage is not there, the digital transistor is not engaged. So that means there is full voltage drop. You see, we get here our V extern over this resistor to the Q11, and that's the reason why we see if this is not there, then we see here full 13.8 volt, or 13.3 it was, sorry. And that is what we have seen here. So we have here at its Thor's 13.3 whatever, and we have it here at the gate. So that means this transistor should not let current through. But we have seen that we have still our 12 volt at our voltage regulator, and consequently we have, our processor with 3.3 volt supplied. On the other hand, we have told by, key press on off, we told the processor, hey, come on, we want to switch off. And therefore, the processor switched and our power engaged was not longer available here. And that means this transistor should close. But it didn't. It did not. So that means the logical consequences, I believe that we have a shorted Q10 between drain and source. And let me see if we can test that with the ohm meter. And again, to remember, still 300 milliamps, also our PA, display is dark. So that means the processor already told the circuit switch off, okay? Okay, so I've set my Keithley to ohm, right? So now you see when we bridge it, so that is almost 0. Now the PA is completely disconnected from our power supply. And that means we should see a high resistance between drain and source. And that is what I'm now probing. Wow, 7.5 ohm. And that is exactly what I thought. So you see, it is permanently bridged, let me call it that way. And that is the reason when, even that the processor is telling here's a switching section, switch off everything, it can't, because we have a short on drain and source. So that means let us take out this little bastard. Okay, so let's try if we can do it together. So that's a little bit tricky behind, you know, the camera. Okay, so here is our little component. So that was no problem. And now we can go ahead. Okay, look here, it's extremely difficult to test those little components, and you see the only thing what the component tester can detect is a diode, nothing else. So that is not a MOSFET any longer. Let's see if we can get contact again. That is difficult with such little components, so you really need to press them down here to the contacts, and you know that is really not easy. But I mean, what we have seen is exactly what we tested in circuit, so that it is maximum diode what we can see, but nothing else. And that means yes, this little MOSFET is gone. Alright, and according to our schematic, it is a RLML5203. So let's see, I believe I should have one in stock. Okay, so drawer 15 should be right. So let me see what we have here. Ah, look here, IRLMM5203. So that's the right one. Let's go for it. Alright, and our new little transistor, MOSFET transistor, is in, and we are, so you see the Q10, everything is nice and clean, so that means we can go for testing. Alright, so we are ready for testing and ready for the truth. Okay, still not connected, our positive cable here, which I now will plug into the power supply, and let's see what happens. Aha, look, so we only have a current draw of 3 milliamps and our power amplifier does not start directly up, so that is a good sign. Okay, so next step, let's try to fire it up. Wow, very, very nice. Can we? Yes, we can. Everything is obviously working. And now the question is, can we switch it off? Yes, we can. So no artifacts any longer. And again, only 3 milliamps. So that means our little power amplifier is back working. Okay, so meanwhile I have tested the PA in all functions. I don't want to bring it on video because it really takes too long and extends the video much too long. But what I want to tell you, so very often these little amplifiers gets used together with for example, for ICOM IC705 or such, so a QRP radio, which does not have the right interface for this power amplifier. So that means you need to always switch the band manually. I mean, that is fine, no problem, but you know, when you are in operation and you use the 705 and you have not the right terminal to connect it directly to the connector on the back side of this PA, it happens to be that in operation you are on the wrong band because you have to always manual adjust it, and then you know it happens. So you blow your PA by simply have here a mismatch, and that is where most of these little linear amplifiers blow up. So it is, from my perspective, a really nice design, but if you do not use the original XIEGU QRP radios together with the right connection so that you can operate the PA automatically by your QRP radio, then it is always a little bit tricky, and it happens to be that you blow it. So that is something I really wanted to bring back in your mind. So if you use it without the right terminal connection, be careful. Okay, and that's it for the day. Hope that was something interesting to you, and hope you learned something, and catch you next time. Bye.